So Raspberry Pi Pico, we can program it in Rust using the repository rp-hal. So I have cloned this repo, and this is what the content look like for the repo. Let's examine cargo.toml. Here you can see the necessary information. Similarly, other files of interest. Memory.x, memory sections are clearly laid out in this memory.x file. Now I have actually RP2040 connected to the system in UFS mode. We have to modify the target runner in this file cargo.config.toml. In this one, target is the thumb v6m none EAPI. Now we have to change the runner to this one, elf uf2 rs-t. I have not been able to get this working with this runner so far. I'm investigating that one. Let's see what happens. We build the example. By the way, if you look at the examples, ls rp-hal source examples, you can see that examples are available in this folder. I2C, Blinky, ADC, multicore P4, PIO, PWM, RTC, SPI, WART, Watchdog, vector table. So lots of examples are available here. Let us try to build one example here and see the example PWM blink. I have copied the extra dollar sign here, so that's why this command is not running. So let us remove that and run it again. Now this is transferring to Pico, and the LED is blinking in PWM mode. If we go to another example, rp-hal, LSRP2040 HAL examples. For examples, we can try Blinky here. Blinky. Let's see what happens. The building. Now we are getting a message that unable to find the mounted Pico. This is becomes once we flash first time, the Raspberry Pi Pico is getting into a mode from the UFS2 mode to master rich mode to the normal mode. I have not been able to find a command to put it back into UFS mode other than to unplug and plug in the device again. So we'll see what we can do. I will also demonstrate the other demos as examples and time permits. Right now, let us look at this RP2040 PWM blink example. This is the example here. Here the RP 2040 HAL is first imported. Then we have from the embedded HAL is set duty cycle, and the RP 2040 HAL we use clock. Then we use the peripheral access crate PAC. Now the second stage bootloader is availed here. The PWM minimum and maximum brightness is set here. The crystal frequency 12 megahertz. Now we go to the entry function main. Then first we have a mutable pack, and then core. Then we get the watchdog. Then we get these clocks. Now we put the single cycle IO block controls. Then we have this GPIO initializations. Then obviously the delay part we are having here. Then PWM initialization happens here. PWM enabling. Now we use the PWM output. Then we have an infinite loop for fading up and down the PWM. 2 for loops are used for that one. First is ramp up and then ramp down when there's a delay of 500 milliseconds. So that's the code. Let's look at the device itself now.